In this question, we're given probability of A and B, and first part we're asked to see that we said that if they are disjoint, then what is probability of A union B? Let's do the first part. Now here the idea is that in general, now if I look at what is true in general, probability of A union B will be found as probability of A plus probability of B minus probability of A and B, A intersection B. The comma represents AND intersection. This is the inclusion-exclusion principle. Inclusion exclusion principle or addition rule of probability This is what holds in general. Now I want to look at two specific cases where A and B are disjoint and when A and B are independent. So let's now recall if two events are disjoint or mutually exclusive. If two events are disjoint, if two events A and B, if two events A and B are disjoint, then A intersection B is going to be equal to the null set or the empty set. And so the probability of A intersection B is going to be equal to 0, right? Because A intersection B is just the null set and the probability of the null or empty set is just equal to 0, right? So probability of A intersection B is 0. Thus for disjoint events, the above formula simplifies to. So in general, the formula is given by the inclusion-exclusion principle, but for disjoint events, because this probability is 0, it just simplifies to a probability A union B is just the probability of A plus probability of B, because A intersection B is a null set and probability of the null set is 0. So probability of A intersection B becomes 0. Now since probability of A is 0.3 and probability of B is 0.6 given, so we're given this. So it turns out the probability of A union B is 0.3 plus 0.6 is equal to 0.9. Now we want to do part B. Now in part B, we're told that instead of being disjoint, what if A and B are independent? So this still holds, right? This formula in general holds. The probability of A union B is probability of A plus probability of B minus probability of A intersection B, right? This is what is the inclusion-exclusion principle or the addition rule of probability. We first looked at the case, but what if A and B are disjoint? So we said this probability of A intersection B turns out to be 0. Right, now let's look at another special case. So now we're looking at part B instead. So part B. Right, so this holds in general. Now if A and B are independent, right? If A and B are independent events, then probability of A and B is just probability of A times probability of B. Like we know for independent events, joint probability is the product of the individual probabilities. So probability of A union B is just probability of A plus probability of B minus probability of A times probability of B. Um, so, um, so we're told since probability of A is 0.3 and probability of B is 0.6, again we're given this. So probability of A union B is going to be 0.3 plus 0.6 minus 0.2 times 0.6 is 0.72. So what we've learned in this question is that in general, we know probability of A union B is probability of A plus probability of B minus probability of A intersection B. This is given to us by the inclusion-exclusion principle or the addition rule of probability. Now we looked at two special cases. So this is the general case. Then we looked at two special cases. One was if A and B are disjoint. Which means that probability of A intersection B is just 0 because A intersection B in this case is just the null set, right? This was part A. right? So if A and B are disjoint, probability of intersection B, so probability of A union B in this case is just the sum of the individual probabilities, right? The second special case we looked at was if A and B are independent. If they're independent, then probability of A intersection B, we know joint probability is the product of the individual probabilities. This was part B. So in this case, probability of A union B was probability of A plus probability of B minus probability of A times probability of B, right? So this is the most general case by the inclusion exclusion principle, and these are two special cases.